Hi everyone, welcome to my Core 2 video. Today what I'm going to do is I'm going to work through the May 2013 exam paper and hopefully explain what I'm doing in each question. So let's begin. The example is OCR, by the way. Trapezium rule with 3 strips of width 2 to estimate the value of that integral. You're going to go straight to your formula book and you're going to write down your trapezium rule, which is on page 5. Okay, so trapezium rule says you can integrate a function y, at least you can approximate its integration by doing a half times h y0 plus yn 2 times all the other y's in between. Okay. Right, now you need to think, I don't use the rest of this formula because I just think we're integrating between 5 and 11 and we want to use 3 strips, so it's going to be 7, 9, 11. Okay, this question has been nice to you and told you the width of each strip, but how I've just shown you is how I would figure out that that has to be 2. Once you've done that, you draw yourself a little table with your x values and your corresponding y values, and you're going to be getting, in this case, 1, 2, 3, 4 y values. Okay, so you're going to be getting y0, y1, y2, y3. So your first x value is 5, then 7, then 9, then 11. Okay, you're going to need your calculator because all you're doing at each point is putting the value of x into the formula y equals 8 over x in this case. So first one, 8 over 5, 8 over 7, 8 over 9, 8 over 11. Okay, and we can approximate between 5 and 11 the integral of this function by doing a half times the height. We've just said that the height is going to be 2. Height of the trapezium, or the width of the trapezium, because they're on the side. Okay, it's like that. So times by 2, times by, now we need all our y values. The first ones we need in the first bracket is 8 over 5 plus 8 over 11. And then you want 2 times, because of this part of the formula, the other y's. So the ones that are left, this one and this one. 8 over 7 plus 8 over 9. Okay, now you grab your calculator. You don't need to put a half times 2 in your calculator, that's just going to go to 1. So you're going to type in 8 over 5 plus 8 over 11 plus 2 times brackets 8 over 7 plus 8 over 9 equals. Okay. How many decimal places does it want? It doesn't tell you, so we give 3 significant figures, or 3 decimal places. Go 6.39, 3 significant figures, and it's an area. So it's going to be square units. Okay, so quite a nice first question if you know what you're doing with the trapezium rule, and it gets you 4 marks in the bag straight away. Question 2, solve the following equations for x between 0 and 360. I don't particularly like how that's written. I would rather see brackets so we know it's a sine of a half x equals 0.8. You have to know your trig graphs off by heart. Sine is this one. Okay, cos is this one. The reason is that cos is cool, so you can grab your snowboard and you can snowboard down cos because it's cool, starts at 1. Sine isn't so cool. Okay, can't snowboard down it, you're just stuck in a hill. Okay, anyway, we're talking about sine, so that's the graph that we're talking about. So to get one solution of this angle, okay, we're going to do sine to minus 1 of 0.8, and we're in degrees. So make sure your calculator is in degrees. Sine to minus 1, 0.8, and we get 53.1 degrees. Okay, that's one answer for a half x. So if you think where you are, always think this is 360, 180, 90 here, and 270 here. Okay, so we've just got an answer of 53.1, which is this distance away from 0. And because the sine graph is symmetrical, we can go this distance again away from 180. So the corresponding answer here is going to be 180 minus 53.1. Okay, so 180 minus answer, 126.9 degrees. But remember, that is for a half x. Okay, so what you need to do is you need to times by 2 to get your two answers, that x equals 106.2 degrees or x equals 253.7 degrees, or 0.8, depends how you want to round. Okay. Right, so that's the first question done. Part 2. Sine of x equals 3 cos of x. For this question, you need to know what you need to learn for core 2, which is sine of an angle divided by cos of the same angle gives you tan of that angle. Okay, so that means that you can spot that you have to divide by cos x to get that sine x over cos x equals 3, aka tan x equals 3. So x equals tan to the minus 1 of 3, which you can put into your calculator. And you get 71.6 degrees. That's one answer. There is a trick for tan. It's a trick for tan because it repeats itself exactly the same every 180 degrees. It's periodic with period length 180 degrees. So that means that my trick for tan is that you can plus 180 to get a new answer or minus 180 to get a new answer. In this case, we're going to plus 180 to get our next answer of 251.6. Okay, if you added another 180 on, you would get another answer, but it would then go to 400 and odd, and your range is only between 0 and 360, so you don't use it. Okay, question 3. Find and simplify the first 3 terms in the binomial expansion of 2 plus 5x to the power 6. Okay, so what you're going to do is you're either going to use Pascal's triangle or you're going to use NCR, and you're going to get the first 3 terms. Now let's think about what's going on. Let's color code this one. Okay, so you've got some brackets to the power of 6. So you've got 2 and you've got 5x. Now, binomial expansion is a really cool way to expand this without having to write out the 6 brackets and times them all together. Okay? And what it does is it uses NCR, which is how many times you're going to choose that item. Now, if from all these brackets you don't pick out any x's, you just pick out the number 2, there's only one way to pick that. And in NCR notation, you had 6 brackets to choose from, and you picked 0 x's. In this case, we're going to use this number as how many x's that we pick. Okay, so 6 brackets to choose from, we don't choose any x's, so we've got 6 2's picked, and they're all multiplied, remember, and no x's picked. That's the first term. The next term, we're going to pick from 6 brackets again. This time we're going to pick 1x. So that means that we've got 5 2's, 2 to the power of 5 because they're multiplied, and 1x. When I'm saying x here, our x is actually 5x, so it's like that. Okay. Next bracket, next time you're going to have the 6 brackets to choose from, and you're going to pick 2 x's. Okay. So that means that you've picked out 4 2's and 2 x's, or in this case, 2 5x's, which are multiplied together. It's very, very important you have a bracket here because the 5x is all squared. That would carry on going. However, the question's just asked for the first 3 terms. So we just need to simplify this now. How many ways to choose 0 from 6? One way, just don't pick anything. 2 to the power of 6 is going to be 64. 6 choose 1. How many ways to choose one thing from 6? There's 6 ways to do that. You can check that on your calculator with the NCR button. 6 choose 1. Okay, 2 to the power of 5. So 6 times 2 to the power of 5. 2 to the power of 5 is 32. Times by 6 is going to be 192. And then times by this other 5. Okay, so 192 times 5, 960x. Okay, the next one, you can actually just type this into your calculator apart from the x. So that x is going to be squared, so is the 5, so that's 25x squared. I'm going to put this into my calculator all in one go. So it's going to be 6, choose 2, times by 2 to the power of 4, times by 5 squared, or 25, gives you 6,000 x squared. Okay, first 3 terms simplified, done, 4 marks. Part 2. In the expansion, 3 plus cx squared times by that expansion that we've just talked about. So I'm hence going to use what we've just done. 64 plus 960x plus 6,000 x squared plus some other stuff. Okay, you'd be going x cubed, x to 4, etc. up to x to the power of 6. Okay, now the question is asking for the coefficient of x. It's talking about the coefficient of your x term. Now, you do not have to make extra work for yourself in this question. Because this bracket is squared, that means you've got 2 of them multiplied at the front. So let's write out the 2 brackets. Okay, 3 plus cx, and then we've done the power of 2 there. We are expanding these 3 brackets essentially with this huge bracket at the end. However, we are only interested in the terms that give you something to do with x. Okay, so I'm just going to show on the brackets which ways you multiply out to get just x involved. So you could do that. Okay, because multiplying 3 brackets is just going to mean everything in each bracket gets multiplied by everything else. And we just are being very focused and picking out the ones that we are interested in. Another way to get just x would be the cx there, the 3, 64. And a final way to do it would be to take the 3 here, the cx here, and the 64 there. They're the only ways you're going to get terms with just x. We do not care about anything else, we just care about the x terms. We know that when we simplify them, we get 4,416 of them. So what we just showed in the expansion of the brackets, the first one is going to be 3cx times 64. The next one is going to be 9 times 960x. The next one is going to be 3cx times 64 again. So in fact, we can just do 2 of the first one because they're the same. Okay. So let's simplify 2 times 3 times by 64. 2 times 3 times 64 on your calculator. 384 cx. 9 times 960. 8640 equals 4416x. They're all to do with the x, so you don't actually need it. You can divide through by x here, and then you can solve this to find c. So you take this away and then divide by 384. Okay, so 4416, take away 8640 divided by 384, and it gives you minus 11. What a nice number. Okay, so the value of c is minus 11. We've been very efficient there. You do not want to spend too long on a 3-mark question by expanding out as much of this as you can. Just pick the ones that you actually need. Question 4. Got an integrate question. This one dx. We do not actually need those brackets there. It's just to show you you're integrating the whole thing. And we're going to integrate one term at a time. Integrate means you're going to be increasing the power. Okay? You actually increase power and divide by the new power. So we increase the power from 3 to 4. We divide by the new power. Done. Increase the power from 1 to 2 and divide by the new power. Minus 6 divided by 2 is minus 3. This is x to 0. Increase the old power, divide by the new power. So basically it just goes to your coefficient of x. Now, you could have had a constant, and when you differentiate, the constant disappears. So when we integrate, we need to put that constant back. So you do need to put plus c. Okay, part B. Integral 24x to minus 3. Same rule applies. Increase the power. When you increase minus 3 by 1, you're actually going to get minus 2. Divide by the new power. 24 divided by minus 2, minus 12. Do not forget the plus c. It's part I done. Part II. Oh, nice question. Integral from a to infinity, 24x to minus 3 dx is 3. Find the value of the constant a. Right, if we were to integrate this, we would find the integral of 24x to minus 3, which we've already done, minus 12x to minus 2. We would be integrating between infinity and a. Okay. So we would be doing the limit as I don't know what notation to write this. You can't really use infinity as a number. Okay, let's do it a proper notation so you can see some good maths. You can't use infinity as a number, so we're going to just use any old number, say k. And we're going to say that k is going to infinity. Okay? And we find the limit as k goes to infinity. So it's going to be, we can use k as a normal number now because we're using the limit of k. So it's going to be minus 12 over k squared. Okay. And you're going to be taking away the second limit. So it's minus 12. This one's a bit nicer because we don't need the limit here. A squared. Right. Now we can think about the limit. If k is getting really, really big, going to infinity, and you're dividing by it, that means that your answer, because you've only got a constant on the top, is going to go to 0 for that. So that means that this definite integral goes to just 12 over a squared. Now we were told that this whole thing equals 3, so 12 over a squared equals 3, aka a squared just times it by a squared divided by 3. 12 over 3 equals 4. Okay, a is a positive constant, so you don't need to worry about plus or minus, you just square root. A is 2. Okay. Question 5. Diagram shows sector BAC of a circle with centre A, radius 16. The angle BAC is 0.8 radians. As soon as you hear the word radians, you might as well go to your calculator and change it to radians straight away. The angle BAC is 0.8 radians, the length of AD is 7. All of that information is on the diagram. Find the area of the region BDC. BDC. So we want this area. Do not fall for the trap of thinking that this is necessarily part of a circle. Okay? A sector of a circle, because it's not. The sector of a circle is here. And you're told that in the question. Circle of centre A. So that was your whole circle. You can't start messing around and making your own circles up because you're not told anything about that. Now, if you remember, area of a sector is a half r squared theta, where theta is in radians. So the area of A, B, C is going to be a half. Radius is 16. 16 squared times by 0.8. You can put that into your calculator. Half times 16 squared times 0.8. 512 over 5. Okay. And now we want to take away the area of this triangle, and that will leave us with the area that we want. Okay. Every triangle, I think of it like this. You've got an angle, you've got a length, you've got a length. It's going to be a half times by this, times by this, times by sine of your angle. Okay. Now, obviously, if these lengths are defined, you've got yourself a triangle when you join it up. So it's a half AB sine C. We usually call that C. Okay. So in this case, A, B, C. So a triangle equals a half times A times B times sine 0.8. This is why it's important to be in radians. So on your calculator, a half times by 16 times by 7 times by sine 0.8. And it gives you a nice decimal there. Okay. So now we're going to do the subtraction. Area DBC equals the sector minus the triangle. Okay, so 512 over 5, take away that. So 512 over 5 minus answer 62.3, and it's centimeters squared. We're talking about area here. Okay, first part done. Second part, find the perimeter of a region BDC. Okay, so we want to know this, which we'll do first. So it's going to be r theta for the arc length equals r theta, where theta is in radians. So it's going to be just 16 times 0.8. 16 times 0.8, 64 over 5. You also need this length, which is a missing length in a triangle. And you also need this length. We'll do the easier one first. It's got to be 16 across because it's a radius. We've already gone 7, so that's 9. So we've got that one, we've got that one. We need the missing length here. Okay. So this is going to be your cosine rule. Just trying to remember if you get given your cosine rule or not. You do. It's on page 1 of the formula book, and it's just called Trigonometry, and it says that a squared equals b squared plus c squared minus 2bc cos a. So if you label this angle as your a, this x is your missing length a, and b and c can be anywhere around here. Okay, so we put this into our formula, missing length a, b squared, which is 16 squared, plus 7 squared, minus 2 times 16 times 7, cos of 0.8, still in radians. Going to work out this right hand side in the calculator. Just type in what's on the right. Try not to make any errors. And you get 148.93761 square root of that. You're going to get 12.2 to 1 decimal place. Okay, so it's going to be 12.2 perimeter. You're going to add them all up. 12.2 plus 64 over 5 plus 9. Okay, 64 over 5. Just doing this on my calculator. 34.004. So we might as well say 34 to 2 decimal places, or whatever you want to say. Okay, 3 significant figures, doesn't really matter. So 34, and it is centimeters. Okay, that's question 5 done. Question 6. Sarah is carrying out a series of experiments which involve using increasing amounts of a chemical. The first experiment she uses 6 grams of a chemical. In the second experiment she uses 7.8 grams of a chemical. Given that the amounts of a chemical used form an arithmetic progression, that means to get from one term to the next, you have to add something, and we usually call it the common difference d. Okay. Find the total amount of chemical used in the first 30 experiments. So, what you do, you also have formulas for this on page 1. Okay, is you first of all write down what A and D are. A is your first term, which is 6. D is your common difference, which is in this case is 1.8, and these are what you're going to use for your formula. Your formula book says that to find the total amount, you can do a half n 2a plus n minus 1 times d, where n is how many terms of a series you want to add up. We're doing the first 30 experiments, so it's going to be the sum up to 30. Half times by 30, we're just putting numbers into an equation now. Okay. 2 times 6 is 12. Plus n minus 1, which is 29, times common difference, 1.8. And you can put that into your calculator. Just do it now. Nope. 30 times a half, 15 times by 2 times 6, 12, plus 29 times 1.8. 963. Okay, and if we want to give units, 963 grams used up. Okay, so much for chemical you've used, 963. Instead, it is given that the amounts of chemical used form a geometric progression. Sarah has a total of 1,800 grams of the chemical available. Show that n, the greatest number of experiments possible, satisfies this inequality. This is what you're aiming for. Okay, that's your target. That is your answer. You cannot use it, I'm afraid. You have to get to that. Okay? So show that question. Okay. So if you start with 6 and then 7.8, if you're multiplying, that means to get from 6 to 7.8, we multiply by a number. We usually call it the common ratio r. Now, a is our initial term, which is still 6, but r we're going to have to get by doing 7.8 divided by 6 to see what we were multiplying by. 7.8 divided by 6, 13 over 10. Okay, aka 1.3. So we're going to use the formula to add up again. Okay, now this time we do not know how many experiments we're doing. So the unknown is going to be the number of experiments. We'll call it big N. And the formula says it's A, 1 minus R to the big N. In this case, 1 minus R. We know what A and R is, so we put them into our formula. So it's 6, 1 minus R, which is 1.3 to the power of N. 1 minus 1.3. So let's just simplify that a little bit. It's going to be 6, 1 minus 1.3 to the n over minus 0.3. Now if you read the question, we know that we've got 1,800 grams of the chemical. So whatever that number is, this has got to be less than, let me just move everything across so I can fit it in. It's got to be less than the total amount that we've got. Okay? And the total amount that we've got is 1,800. So we can solve this inequality. Now the first thing that I'm going to do is going to be to multiply by minus 0.3. That's going to switch the inequality sign around. Okay, because we're timesing by a negative. So 6, 1 minus 1.3 to the n. Switch the inequality sign around and do 1,800 times by minus 0.3 minus 540. Okay, now we're going to divide by the 6. Divide by 6, 90. Minus 90. Now we're going to take away 1. So minus 1.3 to n. Now we think this is our target up here. We've got something very similar. We're just going to times by minus 1 to get 1.3 to the n less than 91. Okay, so we've done the first bit. We've shown this. But read the rest of the question. Always check to answer you've answered it all. Use logarithms to find the value of n. Remember what n is representing. N is representing the greatest number of experiments possible. So it has to be a whole number. Okay, so what we're going to do is we're going to take log of both sides of this equation. And we get that log 1.3 to the n is less than log of 91. Okay, now you can bring your n up to the front using your power laws for logs. Now you're going to divide by log of 1.3. Now, remember if we divide by a negative, we're going to have to change the inequality sign. So check on your calculator to see if log of 1.3 is negative or positive. It's positive, so we don't have to worry. Now on your calculator you can actually do log of 91 divided by log of 1.3. Log of 91 divided by log of 1.3 is 17.1. Well, 17.19. Okay. Now, the maths has told us that n is less than this, but your head should tell you as well. Because how many experiments can you do if you've got enough for 17.2? You can only do 17 experiments. Okay, so think carefully. You can't give a decimal as your answer there, I'm afraid. Okay. Question 7. The diagram shows the curve y equals x to the power 3 over 2 minus 1. So here is the curve and the equation y equals x to the power 3 over 2 minus 1. And it crosses the x-axis at 1, 0. So that information is not shown on the diagram that it crosses at 1, 0. Okay. And it also shows the tangent to the curve at the point 47 is the straight line. Show that the integral between 4 and 1 of this function, which happens to be your equation, is 9 and 2/5. So what we're going to have to do is we're going to have to integrate. Let's see if we can fit it in this space. Okay. So when we integrate x to the power of 3 over 2, we increase the power and we divide by the new power. So the power goes to 5 over 2. When we divide by a fraction, it's the same as multiplying by the reciprocal. And minus 1 goes to minus x between 4 and 1. Remember, it is a calculator paper, so you can have your calculator to help you with any of this if you need it. So the first limit that we evaluate, the 4, 2 to the power 4 to 5 over 2 over 5 minus 4. And the lower limit, 2 times 1 to the power of all that, which is just 1 over 5 minus 1. You can put all that into your calculator. And I'm hoping it's going to give you 9 and 2/5. Okay, so 2 times by 4 to the power of 5 over 2. Power of 5 over 2. That's 64 divided by 5. and you're going to be minusing 4. When you minus 4, that's the same as minusing 20 over 5. Okay, and this lower one, obviously that's 2 over 5 minus 1. 2/5 minus 1 is minus 3/5. And because we're taking away, we add 3/5. Okay. I know this is a bit dodgy working out, but there's not much space, to be honest. That's the only reason. Okay. So 64 minus 20 is going to be 44. Add 3, 47 over 5, which is 9 and 2/5. Okay, so you've proved it. 4 marks for that, not too bad. Hence, notice the word hence, you're probably going to be using something that you've already done. Find the exact area of the shaded region. You can see the very thin strip, that's the shaded region, enclosed by the curve, the tangent, and the x-axis. Now the important thing to notice is that there's a triangle below, and if we figure out this triangle, we can take it away from what we've just found, which is that complete area. So that's our plan of action. We've just found this highlighted region. We want to take away this triangle to be left with just a thin slice. To be able to find the area of a triangle, what you need to do is you need to have the base and the height. At the minute, we only have the height. We know the height is 7. Okay. Now remember that the straight line was the tangent line. So tangent to that. When you're talking about tangent, you're talking about gradient. And the gradient we get by differentiating to get the gradient function. So here we times by the power and decrease the power. D for differentiation, D for decrease. Okay. Now that is just the gradient function. Okay, that tells you the gradient at any point. We're interested in when x is 4. Okay, because that's where our coordinate is. That's where the tangent is meeting. So when x is 4, we're going to get 3 over 2 times by 4 to the half, which is the square root of 4. Okay, square root of 4 is 2. So the 2's are going to cancel. That just gives you 3. So 3 is the gradient. So you have that m is 3, and you have a point 4, 7. From core 1, you know that all you need is a gradient and a point to get the equation of a line. So you're going to use the formula y minus y1 equals m times x minus x1. Okay, so it's going to be y minus 7 equals 3, x minus 4. Y minus 7 equals 3x minus 12 plus the 7. Y equals 3x minus 5. That is the equation of this tangent line. Okay, so to know when it crosses, we want to know about when y equals 0. And that means that 3x equals 5, aka x equals 5 over 3. So we've got a triangle, okay, and the width of the triangle, the base, is 4 minus 5 over 3. Okay, 4 minus 5 over 3, 7 over 3 is the width. So area of the triangle equals a half times the base times the height. Okay, so it's going to be 49 over 6. And we've just figured out in the previous question, the total area. Okay, so shaded region, we're going to get by doing the curvy bit minus the triangle. I know the triangle is not too accurate, but you get the idea. Okay, so it's going to be 9 and 2/5, or a better way to write that, 47 over 5. Don't like 9 and 2/5. 47 over 5 minus 49 over 6. And you can do that on your calculator. 47 over 5. Obviously you could do it in your head or a written method, but you want to save time. And you get 37 over 30 square units. Okay, moving on. Question 8. The diagram shows the curves y equals a to the power of x and y equals 4b to the power of x. Okay, so two equations. Part IA, state the coordinates of points of intersection of y equals a to the x with the y-axis. Now, if you think about the y-axis, that is when x equals 0. Anything to the power of 0 is 1. Okay, so it doesn't matter what this value of a is, it's going to cross at 1. Part B, state the coordinates of a point of intersection of y equals 4b to the power of x with the y-axis. Again, x equals 1, so x equals 0, so b to the power of x is 1, so that's going to be 4. Okay, so that means that you've identified that the top one must be y equals a to the x, and the other graph must be y equals b to the power of x, because obviously 4 is bigger than 1. 4b to the power of x. Okay, and that answer is a coordinate, so that was a close one. So the coordinates is going to be 0, 1 there, and 0, 4 there. Okay, make sure we give the question what it asks for. Part C, state the possible value for A, the possible value for B. Now, A is your standard exponential graph, so it could be e to the power of x, it could be 2 to the power of x, it could be 3 to the power of x, okay, anything like that. So you could say A equals 2. Now, state a possible value for B. So let's think about B. B goes the other way around, okay? So what you know about B is it must be a fraction, okay? It's a fraction. We know it's a fraction because it's getting smaller and smaller and smaller the bigger the power of x you raise it to. So for example, a half to the power of 8 is smaller than a half, okay? However, 2 to the power of 8 is bigger than 2. So could say that b equals a half. Okay, as long as it's a fraction, that one's okay. Right, moving on. The diagram shows, yeah, we've read that. Part 2, it's now given that AB equals 2. Show that the coordinates of a point of intersection of y equals a to the x and y equals b to the x, which is here, can be written as this horrible looking expression. So what we're actually solving is simultaneous equations that y equals a to the x and y equals b to the x. I've missed out the 4, sorry, 4b to the x. So a to the x equals 4b to the x. Okay, you can kind of cheat here and think what I want is something with log to base 2 in. So I'm actually going to use that to know what to do with this question. I'm going to take log to base 2 of both sides of that equation. Okay, so log to base 2 of ax equals log to base 2 for b to the power of x. Now we need to use our log laws to try and simplify. Log laws state that we can bring our power to the front on the left hand side, not quite on the right hand side yet, because it needs to be everything to the power, and at the minute the 4 isn't to the power of x, so we'll deal with that in a second. So it's x log to base 2 of a. On the right hand side we're going to use a different power law. We're going to use the fact that when you're multiplying and it's 4 times b to the x, you can add logs. Log to the base 2 of 4 plus log to the base 2 of b to the x. Now we can bring down our power of x. Okay, so it's going to be x log 2a equals log 2 of 4. We'll talk about this in a second. Plus x log to the base 2b. Right, log to the base 2 of something means what power do you have to raise 2 by to get it? Okay, so what power do you have to raise 2 by to get 4? The answer to that is 2. So you've got log x log to the base 2 of a equals 2 plus x log to the base 2 of b. Now we're going to simplify by taking away, okay, don't know what's happened to b in this equation, but we'll see. Anyway, x log to the base 2 of a, it's going to be minus x log to the base 2 of b equals 2. We factorise out our x to get x log to the base 2 of a minus log to the base 2 of b equals 2. Okay, because of our log laws, we can say that that's going to be a division. X log to the base 2 of a over b equals 2. And now, I knew we needed some more information. We need to get rid of b. Okay, so we're going to use this info now, that a times b is 2. That means we can get rid of b by saying that it's 2 over a. Okay, so this therefore means x log to the base 2 of a. I might have done a bit of extra stuff I didn't have to there, but we'll see. A over 2 over a by subbing in our b. Now I'm not going to write it like that, it looks horrible as a fraction. What we're going to do is think we're dividing and dividing again, so it's actually a squared over 2. Okay, and then we're going to split the log up again, but we'll do that in a second. Sometimes you go the long way around things, but you can get there eventually if you keep using maths in the right way. So what I mean is we've got this division and we want to split it up. So we want log to the base 2 of a squared. You can incidentally bring the 2 to the front. Okay. And you get minus, because it's divide, log to the base 2 of 2 equals 2. That's all multiplied by x. We can now divide by that, and we get x equals 2 over 2 log to the base 2 of a minus log to the base 2 of 2. What do you have to raise 2 by to get 2? The answer is 1. Okay, so we got to the answer there eventually. I know it's a bit crammed, but that was the nature of quite a long question, not much space on the board, so do apologise about that one. Moving on to question 9. Cubic polynomial f of x equals 4x cubed minus 7x minus 3. Find the remainder when f of x is divided by x minus 2. Okay, so find the remainder divided by x minus 2. What you can do is set this bracket to 0 and find f of 2, and that will give you the remainder when you divide by x minus 2. So we're subbing in for x 2. Okay, so 4 times by 2 cubed You can do this on your calculator or in your head. Minus 7 times 2 minus 3 should give you 15. Okay, remainder equals 15. What we just used there is the remainder theorem. Okay. You could have done that by long division, but we didn't. Okay, it's quicker to use the remainder theorem. Part 2 is going to force you to do long division by showing something is a factor and then factorize. Okay, so we want to factorize fully. So there's a couple of ways to go about this. Personally, I would go about it by trying a long division. You could go about it by guessing of the factors and seeing when f of x equals 0. But I'm going the long division route. Okay, so we're dividing our polynomial 4x cubed minus 7x minus 3 by 2x plus 1. So for your long division method, you think 2x to 4x cubed. And by the way, you need an extra something in here because I've just realized we forgot some place value. We need 0x squared. You need a column for every single power of x possible for this method. Okay, so you think, what do I have to times 2x by to get 4x cubed? The answer is 2x squared. So we times 2x squared by all of this. 2x squared by 2x gives us the 4x cubed that we wanted. 2x squared times the plus 1 gives us plus 2x squared. That's why it's important to have the columns, because we're now going to eliminate by subtracting this way. And the 4x cubed and the 4x cubed cancel. And we're going to have minus 2x squared when we take 2x squared from 0x squared. We must bring down our next term. And now we must try again and think, what do we times 2x by to get minus 2x squared? The answer is minus x. So we times minus x by all of this, and we get minus 2x squared minus x. We eliminate by going down and taking away. So these two cancel, and you're going to have minus 7x minus minus x, which is minus 7x plus x, which is minus 6x. Okay, you bring down your minus 3, and then you think, what do you have to times 2x by to get minus 6x? The answer is minus 3. So you times minus 3 by all of this, and you get minus 6x minus 3, and it cancels perfectly. So it's a factor. So now what we've done is we've managed to factorize 4x cubed minus 7x minus 3 into the divisor 2x plus 1 times by your quotient 2x squared minus x minus 3. It's asked us to factorize completely. So we now need to factorize this quadratic. I have a nice way to factorize quadratics. There is a different video that I've done on this. If you've not seen it, just bear with me. If it doesn't make sense, you might want to check it out, to be honest. Okay. So what I do is I put 2x in both brackets. And I think what multiplies to make 2 times minus 3 minus 6 and adds to make minus 1. Coefficient of minus x. So the two numbers are going to be minus 3 plus 2. Okay. And now that isn't over because I cheated at the start by putting 2x and 2x. I actually made everything twice as big as it should have been. So I have to divide by a half. And I can divide by a half in the third bracket, x plus 1. We factorized completely, and that is 6 marks. Okay, using long division. That is, oh, we've got one last part by the look of it. So we've gone all that effort to factorize something, and now you're given a horrible trigonometric equation, but you think that looks very similar to what I've just done, but with cos theta instead of x. Okay? So if you let y equals that, then what you get is 4y cubed minus 7y minus 3 equals 0. We know what that factorizes to because we've just done it. 2y plus 1. 2y minus 3. And y plus 1. Okay. Can you see it's exactly the same as this, but with the cos theta instead of the x? It's a disguised cubic in this case. That equals 0. Okay. So this means that y equals minus a half. This means that y equals 3 over 2. This means that y equals minus 1. Now we're not talking about y. Y was a substitution so that we didn't have to keep writing out cos x. Okay, cos is cool. It starts at 1 and it goes like that for one period. You've got 180 in the middle. You've got 360 degrees here. Okay, and we're not working in degrees, so let me scrap that and put degrees because I've just noticed the radians here. 360 degrees is 2 pi. 180 is pi, 90 is pi over 2, and 270 is 3 pi over 2. Give each solution for theta in exact form, and we have to solve that equation. Now, cos only goes between 1 and minus 1. So it's okay to solve cos theta equals minus a half. That's fine. You can put cos to minus 1 of minus a half in your calculator. Okay. And hopefully you've got a calculator that does exact form for you. Not sure if mine's set up right. Mine's in degrees anyway, so it's giving me 120 degrees, so I might as well convert it a long way. 120 is a third of 360. So it's going to be 2 pi over 3. Okay, it probably would have given it you if you did that in radians. So 2 pi over 3. On the graph, it's somewhere around here. Okay, it was 120 or 2 pi over 3. So the other answer that you want to not forget is here. Okay, so that was 2 pi over 3 from 0. Okay, you want to go the same distance because cos is symmetrical. Okay, here, that's your line of symmetry. You want to go the same distance from 2 pi. Okay, or 2 pi minus 2 pi over 3. And that's going to give you, I think, 4 pi over 3. Because, yeah, 4 pi over 3. So that's two answers from that one. If cos theta equals 3 over 2, that means 1.5. That is no solutions. Okay, no solutions. Y equals minus 1 is okay. You can solve that. Minus 1 is here, which we've already said is the halfway point at 180 degrees or at pi. So theta equals pi, 2 pi over 3 or 4 pi over 3. They are all of your possible answers done. We expected 3 answers because it is a cubic. Right, I hope that's been useful. That's my first Core 2 video that I've done the whole paper on. If you notice anything I might have done wrong, just give me a shout. Or if you have any questions, then just make a comment. Hope you like it, subscribe for more, and achieve maths.